Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of thermal properties of matter, where we discussed the questions related to the calorimetry concept. So we have solved n number of questions related to the calorimetry, right? So latent heat and specific heat capacity, the heat capacity or the thermal capacity, all these concepts we discussed in the last session, right? So today we are going to deal with the lecture number 4, where in lecture number 4 we are going to focus on the heat transfer. So and first we'll discuss heating curves, so then we'll go for the heat transfer concept. Okay, I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you for the next 1 hour, and at the end of the lecture it's very important to prepare your own short notes, and competitive examinations are around, so you guys have to gear up your preparation. If you are in class 12th or dropper, so attempt more mock test, complete the syllabus as soon as possible, clear your backlogs from class 11th and class 12th, and make your own short notes and revise it daily. So then do the previous year questions. So this is a regular practice you should do. Okay, chalo. So let's go for the today's concept. So first let's go for the heating curve. So see, let's understand this heating curve through an example. So the heating curves actually between, so the temperature versus heat, it's a graph between, or the curve between temperature versus heat. Okay, chalo. Now here, so let me take an example. So through example we can understand better. So draw a plot of heat versus temperature, temperature versus heat, temperature versus heat of x grams or some mass, x grams of ice, which is at, let's say, minus 10 degrees centigrade. It is at minus 10 degrees centigrade. So melted to 11 degree centigrade. Okay, chalo. So this is a concept. So the question is given. So now you have to draw the plot of temperature versus heat of x grams of ice. So some mass of ice, so which is at minus 10 degrees centigrade and melted to 110 degrees centigrade. So first thing is, so what are the temperatures involved in it? So what are the heat transfers involved in it? See, first it is existing at minus 10 degrees centigrade, which is ice, right? So from here it will reach 0 degrees ice. Yes. So here to here, so what happens? So the latent heat of fusion. Yes or no? So the heat, that is m, not latent heat, so the heat transfer takes place, mc delta t. So the mass of the ice into, so the specific heat of the ice into delta t. So and then from ice at 0 degrees centigrade to, so it will become water at 0 degrees centigrade, water at 0 degrees centigrade. So here the latent heat of fusion, so the mass of ice into, so the latent heat of fusion, the heat absorbed. So here the heat absorbed is this much, MICI delta T. Next, so 0 degrees centigrade to, so the temperature changes to 100 degrees centigrade, again water. Yes. So now, so here whatever the heat that is, so MC delta T again, so mass of water into specific heat of water into delta T. So now 100 degrees centigrade to water will become again same temperature 100 degrees centigrade, so steam. So here latent heat of vaporization, so here mass of water into, so the latent heat of vaporization LV, and then so from steam to here 110 degrees centigrade, steam to 110 degrees centigrade, again it converts to steam. Yes or no? So here what's the temperature change involved? MC delta T. So the temperature changed. Yes or no? 100 degree centigrade to 110 degree centigrade, 110 degree centigrade steam. Clear? Understood? So these are all the temperatures involved in changing the temperature from minus 10 degree centigrade to 100 degree centigrade, sorry, 11 degree centigrade. Yes or no? Chalo. So next, so here what we can write, mass of the steam into specific heat of the steam into delta T. So now you have to plot these in the temperature versus heat curve. So how do we draw? Just understand the concepts carefully, that's it. So basic things only. Chalo. So now let's draw the curve. So let me take So now see, it is initially at minus 10 degree centigrade. So I am considering, let's suppose, so 0 degree centigrade somewhere around here. So then minus 10 degree centigrade I am considering here. Okay, so reference point I can consider wherever I want, and some standard temperature I am considering 100 degree centigrade here, and then so here 110 degree centigrade. Okay, so first it's increasing its temperature from where to where? Minus 10 degrees centigrade to 0 degrees centigrade. So minus 10 degrees centigrade to 0 degrees. So let me draw with the other color. So here, yes or no? So minus 10 degrees centigrade to 0 degrees centigrade. And then at 0 degrees, the state change occurs, temperature increases. This is a temperature versus heat. The temperature versus heat. So here, the state change occurs, heat, still you are supplying the heat, but that heat is used in change in state. Yes. So then from 0 degree centigrade to again 100 degree centigrade. So 100 degree centigrade. So here, yes or no? So 0 degree centigrade to 100 degree centigrade temperature change. So then again the state change occurs at the 100 degree centigrade. So from 100 degree centigrade again the state change occurs. So then it becomes steam from there. So 11 degree centigrade. Clear? So everyone understood? So here whatever the heat that you supplied, it is MLF, right? So and then here MLV, the latent heat of vaporization. This is the latent heat of fusion. So this is called the heat curve of the particular situation. So this situation. Done, everyone? So just note this down. So note this point quickly. Done. Over. Chal. So that's it. So 1110 also there, right? So again temperature increases from here to here. Done. So now this is a heat curve. So here in this heat curve, so let's name these points. So let me consider this is point A. So the point B, point C, point D, and point E, and point F. Yes. So now here to here, so the heat changes, so the state change occurs, but the heat supplied here will be less than that of here. Why? Because the latent heat of vaporization will be obviously more, and this will be less. So that's why here it is going to be less and it is going to be more. So while drawing also I represented this area as small and this line as somewhat big. Okay, clear? Understood? Chal. So and then one more thing here. So let's find the slope of this curve. So the slope of heating curve. So where do we find slope? Let's say the slope of CD part. So shall we say? So the slope of CD part is equals to, so delta y by delta x, the change in y by change in x. So what is change in y? Delta t by, so in the x what is there? What is there in the x? So delta L by delta H. In the x direction we have heat only, right? So what kind of heat is there from here to here? So the heat from C to D. What is the heat from C to D? So let's say this is from A to B, B to C, C to D. So C to D, the heat supplied is MC delta T. So here in place of this delta H, I am writing the heat supplied, or delta Q also you can write, your wish. Delta Q or delta H, whatever it is. So here MC delta T. So here delta T cancel. So 1 by MC. 1 by mc, mass into the specific heat capacity. So the slope of heating curve so is giving 1 by mass into specific heat capacity, so which is nothing but the slope is equals to, shall I say, 1 by the thermal capacity, 1 by the thermal capacity. Done? Understood this part? So just the concept, have the basics properly, understand the basics properly so that you can solve the questions easily. Done, everyone? Chalo. So this is also done. Next, so now find specific heat capacity of solid, so of mass 2 grams. So I'll give the graph for this. Let's say, so we are drawing the, so the temperature, heat versus temperature. So let's say, so it is changed from minus 10 degrees centigrade to, so 10 degrees centigrade. Okay, so which is at, so let me consider this as 100 calorie. So now try this question on your own. I gave the graph, you have to find the specific heat capacity of this graph, of mass also given, which is 2 grams. Specific heat capacity, you can draw if you want, you can keep like this. Chalo. So find the specific heat capacity. How do you find? So try that question on your own. Simple question. See, so we know that the slope is equals to 1 by the thermal capacity, capital C. What is the slope here? The change in y by the change in x. What is the change in y? Delta T by, so the change in x is heat transfer, so which is equals to 1 by C, right, the thermal capacity. So now let me write what is the change in temperature, minus 10 to 10, which is 20, and the heat transfer is 100 calorie, so which is equals to, so 1 by C is nothing but, capital C is nothing but mass into the specific heat capacity. This is the thermal capacity. This is a thermal capacity or heat capacity we say. Okay, so capital C, and this small c is a specific heat capacity. Now, so we can write here, so 20 by 100, so which is 1 by 5 is equals to 1 by, so this is 2 into C. So from here, so 2 into C is equals to 5. So here C will be equals to 5 by 2. So that's it. That's what we required. The C is equals to 5 by 2. So this way you can find, or you can also find this way. So the specific heat capacity, the heat change Q is equals to mc delta T. So this way also you can find. So Q is given 100, mass is what, 2 grams, into C we have to find delta T 20. So then C is equals to 100 by 40, right? So then 0 0 cancel, 2 5s are 2 2s are, so 5 by 2. So same thing, either you can find it by the method we studied just now, or this formula you already know in the previous classes. So anyway you can calculate it. Hope you guys are understanding the concepts. So heating curves, how do we draw? Different change in temperatures or change in states. So for that we draw the heating curve. Okay, heat versus temperature or temperature versus heat. So let's see one question based on that. So we have a block of ice which is at minus 10 degrees centigrade is slowly heated and converted to steam at 100 degrees centigrade. So which of the following curve represent the phenomenon qualitatively? So first it is at minus 10 degrees centigrade. So what happens, minus 10 degrees centigrade ice, it will become 0 degrees ice, right? And then 0 degrees water, then 100 degrees water, right? And then 100 degrees steam. Yes or no? So here there is no state change. First the temperature increases. See here, if you draw, first the temperature increases, so then it remains constant, and then again it increases, and again it remains constant. So check for this kind of curve. Where do we have that curve? So increases constant, increases constant, the first one, temperature versus heat supplied. So here it's decreasing, no, not this one. And then this one, temperature. So here first state change is there, so not possible. So this is also wrong. And then this one, so if first increases and then constant vertically, no, temperature is not constant, temperature increases. Here temperature given, heat supplied is constant, it is given, no. Done guys, understood, clear? Chalo. So the option 1 is the correct one. So now let's go for the next concept, that is heat transfer. So there are 3 different modes of heat transfer which you already know. One is a conduction, the other one is a convection, the other one is a radiation. So let me explain one by one. We are going to deal with conduction part today. So first let me give the definitions of each one. So conduction. So first, what is conduction? So conduction occurs due to oscillation of molecules. Okay, first thing is the conduction occurs due to oscillation of molecules. So here in conduction, the heat transfer takes place from one molecule to the another molecule. So the first molecule takes the heat and it gives to the next molecule, and then the second molecule takes the heat and it gives to the third molecule. So like that, so the heat transfer takes place from molecule to molecule. Okay, so the heat transfer takes place from molecule to molecule. Right, so this is a direct method. That means, so here let's suppose, so in this vessel, so if you heat this vessel, what happens? This molecule transfers a heat to this one, and this molecule transfers a heat to this one, and this molecule transfers a heat to this one. So like that, the heat transfer takes place from molecule to molecule. The molecules in the vessel are in some medium, they oscillate. So due to the oscillation, the energy transfer, the heat transfer takes place between the molecules. So that's the conduction part. And coming to the convection, so here what happens is, so once the molecule takes the heat, the layers of heat here, one more thing about the conduction. So generally it occurs in the solids. So for the conduction, generally considered in solids. Okay, so in fluids and gases also the conduction process occurs, but in solids it will be more. So solids, it is greater than liquids, so then gases. Clear? Chalo. So this is a simple definition. So now what is convection? The second definition, so that is we can write what is convection. So convection is nothing but, so the layers of fluid molecules, so the layers of liquid or layers of fluid, so they take the heat and they leave from there and give away chance to the next layer. Okay, so for example, so this is the top layer. So the top layer will take the heat and then it will move. So it will give chance to the next layer, and it will take the heat and it will give chance to the next layer. So like that, the heat transfer takes place layer by layer. Okay, so here the heat transfer takes place layer by layer, layer by layer. Okay, so here first layer takes the heat and it goes away, and second layer will come up, it will take the heat and again it will go away. So the third layer will come up, it will take the heat and go away. So like that, so the heat transfer takes place. So this convection is generally in liquids. The convection is only in liquids. And then coming to the radiation. So the third is the radiation. So radiation is nothing but, it's an electromagnetic wave. So it do not require any medium. So the first thing is, so it do not require any medium. Okay, so just understand the theory part. We are going for the calculations, the heat transfer concept we'll study in detail. So and we'll solve the questions based on that. So but first understand the basics of the heat transfer. Okay, so then, so the radiation is through the electromagnetic waves. It do not require any medium. So what are these electromagnetic waves? So what is their range? So all these things you'll study in the chapter called electromagnetic waves. We have the separate chapter for that. So in class 12th, so there we'll study it. Okay. So as of now, so the radiation do not require any medium. So the heat transfer takes place through electromagnetic waves. Clear? Chalo, good. So these are the three modes of heat transfer. Okay, done. Chalo. So that's what same thing I wrote here. So actually we do not require this slide. So conduction, convection and radiation. So now, so let's discuss about the conduction in today's session. So then we'll go for the radiation next. So conduction occurs due to oscillation of molecules. So let's suppose this is a rod. So now you are heating this rod with some temperature here. So you are heating this one. So what happens? So the molecules here, they vibrate and they transfer the heat to the next molecules, and they vibrate. So they transfer the heat to the next molecules. Like that, the heat energy or the heat transfer takes place from one end to the another end. Yes or no? Here the heat will be more, here the heat will be less. So then only the heat flow takes place. Understand the basics. So heat flow takes place whenever there is a temperature difference. If there is no temperature difference, so the heat flow will not take place. The first thing. So it's just like the current. You have studied in class 10th current chapter, right? Electricity chapter. So there you have studied that whenever there is a potential difference, so then the current flows from higher potential to the lower potential. Here also the same thing. Whenever there is a temperature difference, here you are heating, the temperature is more, at this end the temperature is less. So consider the temperature T1 here. So then the temperature T2. Obviously the T1 should be greater than T2. So whenever there is a temperature change, if there is temperature change, so then only, so the heat transfer takes place. Then only the heat transfer takes place. Clear everyone? Basics. Chalo. So now it generally occurs in the solids, right? So this heat transfer so can be steady state or unsteady state. Okay, first we will understand. So what is the steady state of heat transfer? So what is steady state and what is the variable state of heat transfer? So see, let's suppose here at this end you are heating this one. So you are heating from this end and again you are heating from this end. So let me explain. So the different scenarios. So from here to here, again you are heating here. So just don't bother about the values. I am going to give some values here. Let's say some initially this has some 60 degrees temperature. So and the beside one, this point has some 50 degrees centigrade, and this point has 40 degrees centigrade, and this point has some 30 degrees centigrade. Okay, chalo. So then you are supplying the heat initially. So then still you are supplying the heat. So this point has changed its temperature to some 80 degrees centigrade, and this point has changed its temperature to some 60 degrees centigrade. So this point 50 degrees centigrade. So this point some 40 degrees centigrade. So the temperature of each cross section increased. So I am considering 4 different cross sections. So we are supplying heat at the one cross section here. So the heat transfer takes place. This is a solid. So the heat transfer takes place due to the vibration of molecule or oscillation of the molecule. So initially you are supplying. So it is 60, 50, 40 and 30. So then only the heat transfer takes place. So then 80. So still you are supplying the temperature heat. So then the temperature difference occurs, but the temperature increases this time. So still you are supplying heat from here to here. So this has reached to some temperature 100 or let's say 90. This point has reached to temperature 90 degrees centigrade, and this one let's say some 70 degrees centigrade. So this point some 60 degrees centigrade, and this point let's say some 50 degrees centigrade. So don't bother about the values, just for your understanding I am giving the values here. Okay. So then from here to here again you are heating. So the heating still continued. So then this point has reached so 100 degrees centigrade. So this has reached some 90 degrees centigrade. So let's say this is some 80 degrees centigrade, and this point, this cross section has reached some 70 degrees centigrade. Now, so even if you supply the heat from here, so the temperature stops increasing. So here, even if you supply the heat here, so the temperature across each cross section becomes constant. That state is known as the steady state. So the temperature across each cross section becomes constant. See, so understand the difference. First, when you are supplying the temperature here, so heat here, so 60 degrees, 50, 40, 30. So then still you are supplying the heat, so its temperature changed to 80, 60, 50, 40. So still you are supplying the heat 90, 70, 60, 50. So still you are supplying the heat 100, 90, 80, 70. So after this, so if you supply more heat also, these temperatures at these cross sections are remaining constant. So they are not changing with respect to the heat supplied. So this state, this is called the steady state. Steady state means temperature need not to be equal at all the cross sections. Steady state means temperature need not to be equal at all the cross sections. No. So but there should be constant temperature at each cross section. So at this cross section 100 degrees, at this cross section 90, at this cross section 80, at this cross section 70. Okay, at different cross sections, so different temperatures will be there, but those temperatures are constant at that particular cross section area. So that's the definition of the steady state. So if the temperatures are not constant at a given cross section area, see here, let's consider this is A scenario, this is B scenario, this is C scenario, let's say this is D. So in A, B, C, so let's say this is first cross section which has 60 degrees initially. Then the first cross section has 80. So the first cross section has 90. So that means the different cross section, the same cross section has having different temperatures. So these three A, B, C are called variable state. A, B, C are called the variable state. Okay, whereas the D1, where the temperature of each cross section is becoming constant, so the D1 is a steady state. So the D1 is a steady state. Understood the definition of steady state now, everyone? So the temperature across each cross section becomes constant, so that is called the steady state of heat transfer. That's it. So but the temperature difference should be there, then only heat transfer takes place. Here 100 and here let's say something 50 or 60, whatever it is. So whenever there is a temperature difference between the two ends, then only the heat transfer takes place. Done? Clear? Chalo. So now under steady state, so the temperature of different cross section of the rod remains constant with time. So that's what I said. So let's say this cross section has some 100 degrees centigrade. It need not to be 100, it can be 80 also. Just for your understanding, I gave the values. So at this cross section let's say 90, at this cross section let's say 80, at this cross section let's say 70 degrees centigrade. So even if you supply the heat, the temperature at this cross section should become constant, that is 100 degrees centigrade. Then only it is said to be the steady state. And then heat passing through each cross section of the rod is same. So whatever the heat passes from here, let's say heat passes Q, so here Q, so here also Q, here also Q. Okay, so very important. Under steady state, the heat passing through each cross section of the rod is same. Very important. Under steady state, so the heat passing through each cross section is same. Very important point, you should note it down. Done? Everyone clear with this? Sure. So let's move further now. So we have got one question. So let's try this question on your own. So under steady state, the temperature of a body increases with time. So under steady state, the temperature increases with time, decreases with time. So the temperature does not change with time and is same at all the points of the body. So the temperature does not change with time, but is different at different points of the body. Yes. So the temperature does not change with time. So it will remain constant, but it is different at different points of the body. Yes or no? Previously we have seen. So here 100, here 90, here 80, here 70. So it is different at different points of the body. Option D is 4 is a correct one, guys. So direct question. Done. This is what? This is a steady state. If they say variable state, so then you can say the temperature changes with time. Yes. So now, so the amount of heat transferred, so which is denoted as Q. So here, how much heat has transferred from this end to this end, it depends on, so the amount of heat transfer is denoted by Q. So it actually depends upon the, so the temperature difference, majorly how much temperature difference is there. So if the heat has to be transferred from this end to this end, so the temperature difference should be there. The T1 should be greater than T2, then only the heat transfer takes place from one end to the another end. Q is directly proportional to T1 minus T2, and the heat transfer is also directly proportional to, so the cross sectional area is also directly proportional to the cross sectional area, and the Q, it is inversely proportional to the length. So if more is the length, so then the heat transfer will be less. If more is the cross sectional area, more will be the heat transfer, and if more is the temperature difference, more will be the heat transfer. Okay. Now, so I can write combinedly all these. So we can write, so Q is equals to, so or else Q is directly proportional to, so A into T1 minus T2, and it is also directly proportional to the time. So let's say it is also directly proportional to the time. So from here I can write Q is directly proportional to cross sectional area, the temperature difference, into the inversely proportional to length, and directly proportional to time. Okay, for how much time the heat is applied to the body. Then, so the Q is equals to, take out the proportional symbol and put the proportional constant Ka T1 minus T2 by L into T, the time T, or which can, this can also be written as Ka, so this temperature difference delta T we write by, so L into, so the time. So this is a heat transfer. So where K is called the thermal conductivity and A is the area of cross section, delta T is the temperature difference, L is the length of the rod, and T is the time. Okay, so let me write again here. So we have got, so the Q, the heat transfer formula, Ka delta T, everyone should remember. So Ka delta T by L into the time T. Okay, so here K is called the thermal conductivity. K is called the thermal conductivity, and then A is the area of cross section. Area of cross section. So then delta T is the temperature difference. So in some reference books they write delta T. So delta theta, sorry. Delta theta, so that is also the temperature difference only. Okay, understood? So delta T is a temperature difference, and then, so what else we have? L is the length of the given rod, and R is a T. T is a time. For how much time heat has supplied to the body. So now let's talk about this K. Here we have K. K is a property of material. So this K, thermal conductivity, it is a property of material. It changes from material to material. Okay, so then here what are the units of K, sir? So let's find what are the units of the thermal conductivity K? So important. So the question can be directly picked from here. So see, in 2019 NEET, so they asked the question based on this direct units of K. So here, so let me write the formula for K first. Q is equals to, I can write Ka delta T by L into, so the time taken from here. So let me write, so the K formula, K is equals to QL by A into delta T, right, into T. Yes. So now let's write the units. So the Q is nothing but heat transfer. So for the heat, the units are joule. Yes. And for length, meter. And for area, meter square. And for temperature change, Kelvin. And for time, let's say seconds. So now here 1 meter gets cancelled. So we can write, so joule per meter Kelvin second. So joule per meter Kelvin second. So here, what is joule per second is also called energy by time. So energy by time, so it can also be represented as a watt power, right? Heat is nothing but energy. Energy by second is nothing but time. So energy by time is the power. Power units watt. So watt per meter Kelvin. So these are the units. So now can you guys write down what is its dimensional formula? So can you write down what is its dimensional formula? You know the dimensions of joule, and you know for the meter and Kelvin and time. So dimensional formula, take it as a homework. So this is homework. Okay, so joule, you know ml square t to the power minus 2. Already I told. So this is L, this is K or theta we write. So this is time. So S. Okay, clear? Chal. Time means T we write. So T, L, here theta you can write for the temperature. And then this is ml square t to the power minus 2. So do it as a homework. So and write the final dimensional formula here. So understood? So either joule per meter Kelvin second or watt per meter Kelvin. Done everyone? So the thermal conductivity units and what is the heat transfer formula. Then. So then the rate of heat transfer is called the heat current. So the rate of heat transfer is called heat current. The rate of heat transfer, the rate of heat transfer is called heat current. So which is denoted with H. Which is denoted with H. So now here I am writing, see, so Q is equals to, so K A delta T by L into the time T. So bring this T to this side. So Q by T is equals to K A delta T by L. So this, the rate of heat transfer, that means heat transfer per time. Heat transfer per time. So this Q by T is called the heat current. So Ka delta T by L. So these are the units, this is a formula for heat current. Heat current. Done. So whenever there is a temperature change, so the heat transfers from one end to another end. So then whenever there is a rate of heat transfer, so the heat current will develop. Done. Chalo. So what are the units now? So units of heat current. Units of heat current. So first write down the formula. So we can write H is equals to, so Ka delta T by L. So we know the K units and we know the area units and we know the delta T and we know the length units. So simply you can write the units of this one. Yes or no? So what are the units? K is nothing but, so joule per meter Kelvin second into, so area meter square. So delta T Kelvin by, so length meter. So that's it. So you can solve it easily. So the heat current units. So here if you can write, so here meter square gets cancelled, Kelvin gets cancelled. So it's a simply joule per second. It is simply, see here, this part units you can remember. This is the heat current, right? So joule per second. Heat is joule per second. This is nothing but the heat current. So H is equals to Q by T. Remember this way. So instead of going for this formula, H is equals to Q by T, right? H is equals to Q by T. So Q units are joule. So time units are second. So joule per second is the units of heat current. Done, everyone? Clear? Chal. So let's move further. So we got one question. So let's try to solve this question on your own. The two ends of rod of length x and a uniform cross section area are kept at temperatures T1 and T2 where T1 is greater than T2. So T1 is greater than T2. Theta 1 is greater than theta 2. Fine. So the rate of heat transfer dq by dt. So through the rod in steady state is given by. So they are asking for dq by dt. So the dq by dt is equals to, we can write Ka into, so the temperature difference is what? Theta 1 minus theta 2. So by, so what is the length? So they gave, so length x. That's it. So that's a rate of heat transfer. K, here a term is missing in the numerator. K, so denominator term is missing here. K a theta 1 minus theta 2 by the length x. Yes. So here K a is missing in the numerator. So option C is the correct one. Done, everyone. Chal. So direct question. So the unit of thermal conductivity K. So the K units, how can we write? So Q is equals to Ka delta T by L into T. So from here K is equals to, we can write QL by A delta T T. A delta T T. See, this delta T is the temperature change and small t is the time. Okay. So this is joule meter by meter square Kelvin second. So meter gets cancelled. Joule per meter Kelvin second, or so we can write joule per second into 1 by meter Kelvin. So joule per second is a watt. So by, so meter Kelvin, or which we can also write, so watt meter inverse Kelvin inverse, right? So watt meter inverse Kelvin inverse, no, watt meter inverse Kelvin inverse. So joule meter Kelvin inverse, no. So joule meter Kelvin, no. So either you can write this way if you want. So you can write this as, so joule meter inverse Kelvin inverse second inverse. Okay, if you want to write it in joules, so this should be the formula. Either this one should be the answer or this one should be the answer. So here I could see that option 2 is the correct one. In terms of joule, both the options given wrong. There is no second inverse in it. So if second inverse is there, so then you can choose this option also. Multi choice correct. Done, everyone? Chalo. So let's see this question. So what's the question says? Try it on your own first. So read the question and try this on your own first. The heat is flowing through cylindrical rods of same material. So both the materials are same. So the diameters of the rods are in the ratio 1:2. Okay, fine. So there are two cylindrical rods. Consider this is the first one and consider this is the second one. So fine. So see, so the diameters of the rods are in the ratio 1:2. So if its diameter is 1, its diameter is 2. So and their lengths are in the ratio 2:1. So 2:1. Fine. So if the temperature difference between their ends is same, so the temperature difference delta T and delta T for both. Okay. And then the ratio of rate of heat flow through them. See here, I can write. So the K is also same because the material is same material, K is also same. So they are asking, So the ratio of heat transfer, so that is H1 by H2. So what's the formula for the first one? K A into delta T. So A1, let's write, K is same for both, K A delta T by, so the length of the first one L1. So K A2 into delta T by the length L2. So because material is same, so the K is same for both, and they said temperature difference is also same. So the only thing that is varying is area and the length, right? So I can write here, so A1 by L1 into, so L2 by A1, L2 by A2, just reverse this one. So then I can write, so L2 by L1, let's write this way, into, so A1 by A2. Chalo. So the cross sectional area can be considered as a circular cross sectional area for the cylinder. So two cylindrical rods. So circular cross sectional area we take. So the length L2, what is their length ratio? The L1 is to L2 is given. The length L1 is to L2, it's given as 2:1. So I can write here 2 by 1. And here, so what we can write in terms of diameters? So let's say pi d1 by 2 whole square for the first one, pi r square, right? Pi r1 square, r1 is nothing but d1 by 2 whole square. So the second one, pi d2 by 2 whole square, right? So pi gets cancelled. So I can write here, so this is 2 by 1 into, so d1 square by 4 by d2 square by 4. So here 4 gets cancelled. 2 by 1 into d1 square by d2 square, right? So 2 by 1 into, the diameters are in the ratio, d1 is 1, d2 is 4. So 1 by 2 whole square is 4. So 1 by 2. So which is nothing but, so the heat transfers are in the ratio of 1:2. Yes or no? So the heat transfers are in the ratio of 1:2. So H1 by H2 only, right? L1 is to L2 is 2 by 1. Yes. So the diameters are in the ratio 1:2. So 1 by 2 whole square. The diameters are in the ratio 1 by d1 square by 4 d2 square by 4. Here some option is given wrong, I guess. This is 4. So 2 by 1. The lengths are 2 by 1 only. So let's check again. So again let's check. So K H1 by H2 is equals to K A1. So K delta T gets cancelled. So A1 by L1 into L2 by A2. Fine. So here L2 by L1 I wrote separately and A1 by A2 I wrote separately. So here L2 by L1 I took it reverse, guys. So this should be 1 by 2. Yeah. Here is a mistake. 1 by 2. So this must be 1 by 2 here. So this must be 1 by 2. So this is 1 by 2. So this is 1 by 2. So which is nothing but 1 by 2 into 2. So 1 by 4, which is nothing but 1 by 4 is a correct answer. 1:4, option 3. See here. Here L1 is to L2 is 2:1. So here L2 by L1 is there, right? So that means, so 1:2, right? You should write reverse. Done? Clear everyone? Chalo. So from now onwards, so what you remember is, so whenever there are change in the dimensions, you remember this way. So if K is same and delta T is same, if K and delta T are same, if K and delta T are same, so the H is directly proportional to what? So the cross sectional area and inversely proportional to the length. Okay. So this is a concept that you should write. So where the H1 by H2 is equals to, you can write A1 by A2 into L2 by L1. So this formula you can remember from now. Okay, for the simpler calculation. So that's what I wrote. So I need not to do all this thing. So I can directly arrive at this formula, L2 by L1 into A1 by A2. So I can directly arrive at this formula. So by looking at the question. Done. Chalo. So we got one more question. So the question number 6. So what's the question says here? Which of the following rods given radius R, length L, each made of the same material? The material is same. So and whose ends are maintained at the same temperature? So material is same means K is same and then delta T is same. in the question, they are maintained, their ends are maintained at the same temperature, will conduct most heat. So which will conduct the most heat? So see here. So let's write. So you have to check the options. The H is directly proportional to what? Cross sectional area, and inversely proportional to length. So here it is given radius r. So which means H is directly proportional to here pi r square by L. So that means H is directly proportional to r square by L. So for each one you have to check r square by L value. So here it comes out to be r square is nothing but r naught square by L naught. So here this value comes out to be 2 r naught square, which is 4 r naught square by L naught. So this value comes out to be r naught square by 2 L naught, and this value, so 2 r naught square, which is 4 r naught square by 2 L naught. So 2 ones are 2 twos are, which is 2 r naught square by L naught. So here I could see that option 2, this value will be more. Yes or no? So this value will be more. So option 2 is the correct one, guys. Done? Clear everyone? Chal. So let's move further. So let's consider the question number 7. So consider two rods of same length and different specific heats, S1 and S2, conductivities K1 and K2. So an area of cross section A1, A2. So both having temperatures T1 and T2 at their ends. So the temperature difference delta T is same for both. So if the rate of loss of due to conductor is equal, so that means the rate of heat transfer is equal. So they are saying, so H1 is equals to H2. So heat current H1 is equals to H2. So for the first one, what we can write the formula? So its K is different, K1, A1. So the area delta T. So let the cross sectional area, so consider two rods of same length. So length L is equals to, so the second rod K2, A2. So the temperature is same, delta T by, so the length is same. So L cancel, delta T cancel. So then we can directly write, so K1 A1 is equals to K2 A2. K1 A1 is equals to K2 A2. So option 1 is a correct answer. Simple questions, direct questions. Done? Chalo. So let's try this question on your own. So what's the question says here? A cylindrical rod having temperature T1 and T2 at its ends. So the rate of flow heat is Q1. So if all linear dimensions are doubled, keeping temperature constant, then rate of flow of heat Q2 will be, see here. So initially, let's suppose, so this is of the rod which is having, so the cross sectional area A. So let the length L. So and the material is same, right? So let's say the K. So now its dimensions doubled. So its dimensions doubled means cross sectional area became 2A, and then so the length becomes 2L. Same material, K remains same, and then keeping the temperature constant. So here delta T and here delta T. So then they are asking what is the rate of heat flow. See, shall I say that if delta T and K are constant, so the heat transfer, so the delta H or H is directly proportional to, so A by L. H is directly proportional to A by L, that's it. So this one you should catch it, guys. So now here the heat transfer is Q2, they said, here the heat transfer is Q1. Done. So now let me do one thing. So the Q2 by Q1 is equals to, so A2 by A1 into L1 by L2. Done. So substitute the values now. A2, so in terms of their radii, so shall we write? So pi, so the first one R, what is the R? 2R. So the radius will become 2R, right? So here the radius will become, let's say R. So here the radius will become 2R. So pi into 2R whole square by here pi into R whole square. So and their length L1 is L and L2 will become 2L. So pi gets cancelled. So I can write here 4R square by R square here. So L cancel. So this is 1 by 2. R square gets cancelled. So then 2 is to 1. Right. So that means, so Q2 by Q1 is equals to 2 by 1. So from there the Q2 is equals to 2 times the Q1. Q2 is equals to 2 times the Q1. Option 2 is the correct one. Understood everyone? Clear? Chalo. So next. So same type of question. Can you guys take it as a homework? A cylindrical metallic rod in thermal contact with 2 reservoirs of heat at its 2 ends. So thermal reservoirs means here this is one, these are the 2 reservoirs. So heat will be constant. That means here some heat Q1, let's say, here the temperature T1, here the temperature T2. So in between 2 rods are placed. Here 1 rod and here is 1 rod. So at its 2 ends conducts an amount of heat. So here there is a temperature difference, heat transfer takes place. So the metallic rod is melted and material is formed into a rod of half the radius of the original rod. Okay, fine. So what is the amount of heat conducted by the new rod? So when placed in thermal contact with the 2 reservoirs in time t. So okay, so same concept. So there are 2 rods. So can you guys take it as a homework? Simple thing. So a metallic rod is melted and material is formed which is rod of half the radius of the original one. So consider the original rod which is of some radius r and the length l. So then, so the second rod is made. So the second rod is made. So which is the radius is half. So the radius is half. So if the radius becomes half, so then what happens to the length? So you have studied the volume conservation, right? So if the radius becomes half, so the length becomes 2L, no? The volume will be conserved. You have studied it in surface areas and volumes in grade 10th levels, right? So if the radius is halved, so the length become double. So then you can apply the same concept here when it is placed in thermal contact with the 2 reservoirs in time. So let the heat here Q1. So let the heat here Q2. So again you can do the same thing. Q2 by Q1 is equals to, I can write the formula. Q is directly proportional to what here? Or H2 by H1. The H2 by H1 is equals to, so we can write the same thing here. So H2 by H1 is equals to A2 by A1 into L1 by L2. A2 by A1 into L1 by L2. So here in place of Q1 and Q2, so H1 and H2, they gave Q2, Q1. So this is heat transfer per time only. Okay, done. So you can solve it easily now. So the second one area pi into r by 2 whole square by, so the first one area pi into r square. So into, so what's the length L1? L1 is L. So the second length becomes 2L. So that's it. So I can write pi cancel. So here r square by, so this 2 square is 4, 4 will come down. So 4 square, right? So 2 square is, this becomes 4. So then, so L by, so this becomes 2L. So the length has become, length will become 4L, right? If the radius is halved, so the length will become 4L. Volume conservation you can apply. See here. So volume, initial volume is equals to the final volume. So what's the initial volume? Pi r square into, so let the initial length be L1. Okay. So and then final volume will become, so pi into r by 2 whole square into, so the length L2. So pi gets cancelled. So I can write r square into L1 is equals to r square by 4 into L2. So r square cancel. L2 will become 4L1, guys. So this is not 2L1, 4L1. 4L1 is nothing but 4L. Here you can write 4L. Yeah. So volume conservation 4L and here 4L. So L cancel. So r square cancel. 1 by 4 into 4, 16. So 1 by 16 is nothing but, so the Q2 we required. So Q2 is equals to Q1 by 16. So Q1 is what in the question? Q. So Q by 16. So the correct answer is option 2. Q by 16. That's it. Done. Simple questions. Okay. Chalo. So one end of copper rod of length 1 meter and area of cross section 10 to the power minus 2 meter square is immersed in boiling water So boiling water means the temperature difference 100, the temperature 100, and the other end in ice 0 degree centigrade. So if the coefficient of thermal conductivity of copper is 92 calorie per meter second, so capital C, and the latent heat of ice is 8 into 10 to the power 4 calorie per kg. So then the amount of ice which will melt, so in 1 minute, so the amount of ice which will melt in 1 minute. See here, so the rate of heat transfer that will be used to melt the height. So the heat required to melt the ice, that's it. This concept, if you can understand, you can solve it easily. So here what we can do, so what's see here, heat transfer, so the rate of heat transfer, so Ka delta T by, so length L into time T is equals to, so the heat required to melt the ice here it is M into L, that's it. So you know all the values, K value you know, area we know, and delta T temperature difference also we know, and the length also we know, and time 1 minute 60 seconds. So what we have to find, so how much ice will melt, small m you have to find, and capital L also given in the question. So can you guys solve it? So what is K here? So K value is 92 into area 10 to the power minus 2 into, so delta T 100 degree centigrade by, so L length, so 1 meter into, so the time T, so what's the time T, so 60 seconds, so into M we have to find, so what is L, so 8 into 10 to the power 4 calorie per kg. So we need it in kg only, so let it be in calorie per kg itself. So then you can, the only unknown is M, so find the value of M, take it as a homework. So just doing the calculations, so take the homework. Done? Simple question again. A slab of stone with area is given, so thickness 0.1 meters is exposed on the lower surface of the steam at 100 degree centigrade. Fine. A block of ice 0 degree centigrade rests on the upper surface of the slab. So in 1 hour 4.8 kg of ice is melted. So the thermal conductivity of the slab is, so same question. So the heat transfer is equals to, so the heat that is used to melt the ice. So done. So here it is Ka delta T by L into the time taken T is equals to M into L. So here this time mass is already given, so L is given, so K you had to find, area is given, temperature difference is given 100 minus 0, and length is given, so length is 0.1, right? So that's it, everything is given, so find the K value. So take these calculations as a homework, simple thing, right? Chala. So that's it guys from my end. So we have studied in today's session, so the heat transfer and the thermal conductivity, okay, conduction part. So in the next class we'll continue some more questions, and then we'll go for the radiation part. Okay, so till then keep studying, all the very best. Bye guys.